Welcome to the Getting Started with Apache Solr presentation by Lucid Imagination. Install Solr 1.3, change into the example directory and launch Solr using java-jar start.jar. After Solr has started, launch your web browser to localhost port 8983/Solr. In another shell, change into the example docs directory and run java-jar post.jar start.xml. This will index several sample files, and then you can browse to the Solr administration page and see how many docs were just indexed. Next, we're going to search with Solr. Using the browser to interface with Solr, we go to the select URL with a Q parameter, a full text query parameter of video, and we see the first page of results are returned to us in XML format with a header that specifies the query time, the status, as well as some parameters are echoed back to us. We can also narrow down the fields that are returned for each document to a specific set specified from the client. In this case, we're going to only request the ID, the name, and the price returned back in the results. By doing this, we can avoid large full text fields coming back to the client if it is unnecessary for the client to have them. Solr also supports a very sophisticated query parser syntax using the Lucene query parser syntax. In this example, we're going to narrow to the name field and only search for the word black within the name field. And we use the name : black Lucene query parser field selection capabilities. It also supports a number of other sophisticated query types. In this case, we're going to do a range query on the price field for all documents that have a price of 0 to 400 and issue that query and get the response back. Next up, we're going to facet, turn on one of Solr's more exciting features, faceting. When we turn on faceting, what we see are the counts per the field that we specified, in this case the category field, the number of documents that exist within the current result set in each one of those categories. So within the price of 0 to 400, we have 10 electronic documents, for example. To filter results in Solr, we can also add FQ parameters for filter query. In this example, we're going to filter to electronics, category electronics, by adding FQ equals cat : electronics. Leaving faceting on, we can see that we've narrowed down to electronics, and it gives us those counts. Further, we can drill into another category for memory. So in this example, we've narrowed to category electronics and category memory, all in one shot. Now let's look at Solr's schema. From the admin page, we can go to schema.xml and browse the various types that are defined there. These are user configurable types. Now we're going to look at the various fields that are defined in the example application. We have ID, SKU, name, category, price. All of these have various field types that define whether a field is stored, indexed, multi-valued, and various other Lucene index related attributes. In this case, you can see the price is a sortable float type. And on down the schema, we also see dynamic fields so that you can have various glob naming patterns for the field types and the fields coming in from the documents. Besides the schema, Solr is also powered by a file called solrconfig.xml. In solrconfig.xml, the heart of this, besides the Lucene indexing parameters, are the request handler configuration. Right here we see the standard request handler, the /select that we've been using, and its default parameters. Not much there other than to echo the parameters. A more sophisticated example in the Solr example application is the partitioned request handler. It's using the dismax query parser. It's got a sophisticated QF parameter for the query fields to be used. It also is limited its results to only in stock items and has also specified a hard-coded set of facets that will be returned for every request when faceting is enabled. Leveraging the partitioned request handler shown in the previous section, let's show how that is used. From the browser, let's go to Qt equals partition. That's selecting the partitioned request handler. We're going to search for iPod, and we're also adding the parameter to echo all parameters from Solr so that we see the ones that are defined in the request handler as well as ones that were provided by the browser. Another feature is that we can turn on faceting. As you saw in the example of the request handler, the faceting configuration was already fixed in the Solr config.xml. All we have to do is say facet equals on as a parameter to turn it on or off to get those facets already hard-coded. And now we can also add a debug query equals true and see more sophisticated output from Solr and examine how the queries are being parsed, as well as explanations for why documents score where they do. In addition, you also get timing information from each of the search components attached to the request handler being used at the time. Let's take a look at Solr's XML format. Browsing to one of the example documents, we see that it's a very simple XML format. It's literally just documents with fields. Fields have names and a textual value. And you can add multiple documents per request. Next is to show how to delete documents from Solr. You can post in an XML document that is delete by ID or delete by query. In this example, we're showing deleting by ID. One of the example documents has an ID of Solr 1000, so we delete that. And then next we delete by query, and we're going to delete all documents which have a category of software. And we're using the stream.body request parameter here to be able to show it through the browser, but normally this is done through an HTTP post. To make document adds or deletes visible to the search interface, we must first issue a commit. The commit process warms Solr caches and brings the updated index online. One final administrative operation is optimize. Optimize squeezes deleted documents out of the index and merges Lucene segments, making searches as performant as possible.